In question 4, the diagram shows part of the graph y equals to a tan of x minus b plus c. Given that b is 0 between 0 and pi, we have to find the value of the constant a, b, and c. So looking at the equation, this b basically represents how much the tan graph has been translated in the x direction. Now, normally tan has an infinite value at 1 upon 2 pi. So at 1 upon 2 pi, it is infinite, and the graph normally goes up like this. Now we can see that instead of 1 upon 2 pi, it is going up to infinity at 3 upon 4 pi. So if we find the difference of 3 upon 4 pi and 1 upon 2 pi, so finding the difference of 3 upon 4 pi minus 1 upon 2 pi, taking the LCM, this will become 3 pi minus 2 pi upon 4. So we can say that the graph has moved forward towards the right by pi upon 4 radians. So the value of b will be is equals to pi upon 4. To find the values of a and c, we can substitute any of these values into the equation. So let's say at x1 upon 4 pi, the value of y is 1. So we can rearrange the equation to write it as y equals to 1 when, well, this is a into tan, x is pi upon 4. The value of b is now pi upon 4 as well, plus c. So tan pi upon 4 minus pi upon 4 is 0, and tan 0 is 0. So 0 plus c will be equals to 1, and c will be equals to 1. Once we have the value of c, now we can say, now to find the value of a, we can again use the expression with a different value. So we'll write it as y is equals to a tan of x minus pi upon 4 plus 1. Now at x1 upon 2 pi, the value is 3. So we'll write it as y equals to 3 when x is pi upon 2. Simplifying this, so pi upon 2 minus pi upon 4 is pi upon 4, and tan of pi upon 4 is 1. So this will become 3 is equals to a plus 1. So a will be is equals to 3 minus 1, which is equals to 2.